There we go. That wasn't bad, actually. Okay. And what goes on the y-axis? The dependent variable. All right, and we're going to look at a little experiment here for looking at graphing it. And in this experiment, we are measuring how far a dog has run at various time intervals. So in this experiment, we have two variables, and I would like you to think, what are those two variables in this experiment? Have a little chit chat with your neighbors. What are the two variables in this experiment? What are the two things we're measuring? I don't even need to know which is which yet. Just what are the two things we're measuring? One is, yeah, the distance the dog runs. So I don't have a lot of room here. I'm just going to write distance. And the other one is time. Okay, and which of those two is independent of the other one? Which one is independent of essentially everything? Sophia? I have to argue with you on that one a little bit. John? Okay, here's the thing about time. Here's the thing about time. Does time care how far the dog has run? No. Will time just keep on going, whether the dog is running or not? Yeah. So anytime you have time, it is almost always the independent variable. So if time is one of the variables, it is almost always the independent variable. Yes? What about speed? Ah, good guess, but the speed is the slope of the line, which you would have to do some math to get. We'll come to that. We'll come to that. That's an exciting thing to do, finding the slope. Okay. So yes. Time, if time is one of the variables, it will almost always be the independent variable. I can't think of any offhand. I'm saying almost to cover my butt. You know what I mean? Like if it happens that it isn't at some point, you know, but I would say 99.999% of the time will be independent. There might be something like where you get close to like the speed of light, and then weird things start to happen to time, weird things start to happen to gravity. It's just weird. When you start traveling near the speed of light, weird stuff happens. I used to watch a lot of, when I was a little kid, I would watch a lot of like science documentaries on PBS with my parents, because there wasn't like this amazing amount of stuff out there to watch. So we basically watched, there was PBS, public broadcasting, there was CBC, there were a few other things. We actually had black and white TV when I was very little, you know, back in the day. So anywho, so time is our independent variable, the IV, and that means that distance is the dependent variable. How far the dog can run depends upon how much time it has had available for running. Does that make sense? Yeah? Okay. So we've now determined what the independent and dependent variables are. You always have to label your axes. Now, what the heck does the word axes mean? And it doesn't mean these things, light axe, heavy axe, double axe. That's not the kind of axes we are talking about. Yes? It's the plural of axis. Okay, so axes is the plural of axis. So the x and y, we don't say the x and y axes, we say the x and y axes. And we need to put two things along each axis. We need to put, number one, the names of the variables. And number two, we also need to give the unit associated with that variable. You're actually going to have a checklist, which is actually in your book if you ever want to look at it. I think it's on page 8, and it will do things like tell you have to label your axes with the name of the variable and the unit. So, looking at our little dog experiment, we know that distance is the dependent variable here. So where should I put distance? Distance is the dependent variable. Do I put it on the x-axis or the y-axis? Y-axis. And if you don't have time to write it horizontally, or sorry, not time, if you don't have room to write it horizontally, you can write it vertically. I'm going to do that because I don't have that much room up here. So I'm going to write distance. Am I finished? No. What else do I need to write? I need to write time on the bottom as well, yes. What else? Unit. So what is the unit for distance? Yes, sorry. You're good? Okay. Yes. Kilometers or meters? I'm going to go with meters because it's just a dog and I'm not going to measure it for that long of a time. How about time? Yes, seconds. Okay, good. So we have distance, we have time, we have labeled our axes. That would be worth 1, 2, 3, 4 marks. Yes? All right, you're always going to give your graph a title. There are several forms that you can write the title. We are going to focus on this one here because it's the easiest. Feel free to read the others and use the others if you want to. But what we're going to do is we're going to use the dependent variable versus the independent variable. In other words, we're going to write y, which is dependent, versus x. But do you think I'm just going to write y? No, what would I write instead of y for this graph? I would write distance. And do you guys know the word, what word that stands for? I mean, I said it, but do you know? VS stands for versus. Okay. So we have distance versus time. And if you wanted to be more specific, you could add something like for a running dog. But for grade 9, I'm going to say that that's optional. Okay, probably if you get into senior physics, they'll want you to like sort of be more specific, but that'll do for grade 9. So on our little graph, where do you think we would write the title? At the top. So we're going to write distance versus time. Okay? And once again, that's going to be worth 2 marks. 1 for getting them in the right order. So you don't want to write y versus x. or sorry, X versus Y, you want to write Y versus X. If you ever have trouble remembering which one to write first, just take a look at your graph. As you're reading, which one do you read first? We read from left to right and top to bottom, right? So here we go. What do we read first? Distance, and then we read time. So it's going to be distance versus time. Distance versus time. Okay, so it's just like reading order, okay? Okay. Now we need to have a good scale. So we're on our next page, we need to have a good scale. 2, 4, 6, 8, 10 is good. What if I had my x-axis and I had here 0, 2, 3, 5, 6, 10. How do we feel about that labeling of the axis? It's painful. Yes, it's painful. Why is it painful? How much is this? That's 2. And then the same distance is now worth 1, and then it's worth 2, and then it's worth 1, and then my gosh, now it's worth 4. So this is inconsistent. You can't do that. You have to always have something along the lines of count by 2s, 2, 4, 6, 8, 10. What would another example of a decent scale be? Something you could count by? You could do 4, 8, 12, 16. That would be fine. You could count by 4s. What else could you do? Yeah. You could count by 5s. 5, 10, 15, 20. That would be fine. Yes. You could literally do 1, 2, 3, 4, 5. You could do 20, 40, 60, 80. Yes. You could do 0.1, 0.2, 0.3. And those would all be okay. What's not okay is when you have this sort of random, and that's wrong. Okay? So they have to be consistent. You should pick things that are easy to go up by. So you can choose things with a 1 or a 2 or a 5, maybe even a 4. Occasionally people have made 3 work, but can you imagine if you're going up by 7? Right? Like you're gonna have to do fractions of a 7, like where if you go 7 and then your next number is 14, then you're gonna have to figure out where is 9? Yeah, like that's a harder thing to do on that scale, yes? So we try to go up by nice normal numbers, okay, nice tidy numbers. Don't go up by 13s, that would be ugly. In science, you are always going to make a scatter plot. Unless it is obvious, you should use another type. And it might be obvious if you're trying to graph groups. So if you're graphing groups, what kind of a graph do you use? You use a bar graph. But I will say, if you continue to study science and you go on and take physics or chemistry, you will never, in those classes, be using a bar graph. You will always be using a scatter plot, okay? Now, this is not, you know how you get like the placemat and this kids menu? Yes, and sometimes it has like a little connect the dots on it. We're not doing the kids menu at Denny's, okay? So we do not play connect the dots. There are times when that is appropriate. You'll often see a graph like that for something like what is the Canadian dollar doing in relation to the American dollar, and you'll see the ups and downs, okay? But again, in science, we want to see this line. What's that line called? That's the best fit line. It's also called the trend line or the line of best fit. So in science, this is what we want. This would be okay for maybe economics or some other things. You are always going to draw a straight line or a smooth curve. And there's not going to be any squiggles either, and we'll talk about squiggles in a moment, okay? Make sure that your data is graphed as large as possible in the space that you have been given. So if you are given a full page, try to take up at least a half to 2/3 of that page. Yeah, so if I give you a full piece of graph paper, use as much of the space as possible. All right, here's an example of a bad graph. I would like you to chat with your partner and decide what is bad about this graph. Oh, the 104, I'm sorry, the 104 is just the page number. Let's just get rid of that because it should not be, I should move it so it's not near the graph. What's one thing that's wrong with this graph? One thing that's wrong with this graph, Jan? Sorry? The dots are connected. We played connect the dots. Another thing, Sophia. There's no title. Sorry, I don't know what's wrong with me there. No title. Sophia. No units. Yes. Yeah, it doesn't, there's no quantity label. Alex. Yeah, what is this 0? Why is the 0 up here? Gosh. Yeah, it's not absolutely necessary for you to label them as X and Y in science. I know in math they're like you have to do that, but in science you don't necessarily have to. Okay? So yeah, we've hit on all of these things that are kind of bad. Now, when I fixed it, I didn't fix, oh, I haven't fixed it. Here, let's look at the fixed version. I still need to fix this a little bit more because it's not really all the way down there. But I made it bigger. It has a title. It has what we're measuring and the units, what we're measuring and the unit, and we have a best fit line. Yeah, the average cost of the speeding ticket and then your speed. I don't know. I don't know why it's all over the map like that, but that's okay. Doesn't the clarity and beauty of this graph just make you want to cry? It's so lovely, oh my God. Okay, moving right along. I don't know. Let's take a look at graph A and B. Which graph is more correct and why? Tell your neighbor, what do you think? Which graph is more correct and why? What do we like? A, why? What's wrong with B? Yes. Yeah, the numbers are uneven. We're going 2, 2, uh-oh, 1, 5. Ah, okay. So that's the kind of question I could give you on a test and be like, which graph is better and why? Neither of them are particularly awesome because they are missing. What are they missing? Tell your partner what they're missing. They're both missing title. They're both missing units. They're both missing the quantity and the best fit line. So there's 4 things on there that are missing, okay? Now, sometimes, so far all our graphs have been linear, and what you should know is that when we say linear, that means a straight line. That is, I think, is it on your vocab list? Can you check? It's on the vocab list? Okay. Sometimes a graph will give a smooth curve, and we're going to look at what makes a curve a smooth curve. You don't need to know any of these kind of names, but if you're into math, if you're like, you know, a grade level ahead or whatever, I know some people do accelerate in math. This is an exponential curve where it starts going up slowly and then it goes up faster and faster and faster and faster. This is where it goes down slowly and then it starts to go down faster and faster and faster and faster. This goes up quickly and then it slows down. We see a lot of these in chemistry, okay? This is an inverse. It goes as 1 over x. So y is equal to 1 over x. Yes? Sorry? It could also have a different name as well. Yeah, I'm not sure. And then this one is called sigmoidal, which is just fun. If you don't know, the Greek letter sigma is the Greek letter S, which is why it's called sigmoidal, because it looks like the letter S. Do you need to know the word sigmoidal? No, you do not. Okay? Shh. And then one of the things my AP chemistry class has been learning about is where you sort of have something that goes up and makes a smooth peak and then comes down. It's a little bit like that. Yeah, yeah. Now, you will never have a curve that just wanders around randomly. This is not a smooth curve. That's playing connect the dots with a curvy line, okay? So let's say that we had our data points were here, 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 here. Does that look like a curve or a straight line? Probably a straight line. What you don't want to do, you don't want to be like, it's a curve. No, no squiggly lines. Okay, no squiggly lines. If you have data like that, you're gonna go, oh, I can just draw a straight line through that. Okay, that is a linear relation. And we're actually ahead of the other class. So if you would like to just do the sample problems, you can do them, you can check them, and then you will have no homework other than just to, if you had difficulty with any of the vocab, you could go and review any vocab you had difficulty with, okay? So why don't you give those sample problems a try? Try and draw a smooth curve or a straight line for each graph. You're going to classify each one of them as either linear, straight line, or non-linear, a smooth curve. So try and either correct the line or draw the line. Use pencil in case you want to change it later. Give me a book. Do you need a? Oh yeah, sure. Layla, do you need a book? Yes. Number 3. Where's number 3? Oh, there it is. You could argue number 3. I would guess that it's curved. I would guess that it's curved. But it's an example that I would not take on a test because it's not like super obvious. And I want things on your test to be like very clear one way or the other. What is the homework? The homework is, whoops. If you had difficulty with any of the vocabulary, you're going to go home and review those things you had difficulty. No, that's okay. You don't have to go through 0. Uh, yeah, for sure. We'll check this next day. We'll go over it next day. You sure can. John, I'll give you that. But it's the old one.